Hi, it's Jim Bergman with MeasureQuick. We got some super exciting news. We've been cranking away on making a gas heating application, and it literally took probably 4 weeks longer than we thought it was going to, just because we decided to add so much more to this. You know, we tied in the AccuTools BluFlame analyzer, and about that same time, Testo called us, and they actually gave us the rights to use the Testo Smart Probe set. So after going through that whole thing, and I realized how much easier it could be with Testo Smart Probes, we decided to add that suite of probes in there and really make this a powerful new application. So I'm going to go through and just show you how to use MeasureQuick now on the gas heating side to set up a gas heating test, and then we'll just go through all the steps and you'll get an idea of how easy and how friendly this new application is. All right, so I'm going to go ahead and I'm going to hit gas furnace test, hit continue, and what I'm going to do though is pick a test I did a little bit earlier just because I have some data that I have fit in there. So I'm going to go ahead and select this test here, and I'm going to set it as active. And what that's going to do is it's going to pre-populate some of the information I already had filled in, just so you don't have to go through that. Now in the project itself, you can see that I have project notes here. I'm set up for the fall tune-up on here. I'll hit submit. My job site information. So if I go in here, you can see it's set up for Jim Bergman, jim@measurequick.com, the phone number. I do have a button here I can select if I have a billing address that's different than the service address. And I have my city, state, and zip, and I'll hit submit on that. Hit submit, and then I can go back in and start filling out my equipment information. So in my equipment information, you can see I have a profile set up for heating only, furnace, ream. I input the model number here, but I do want to grab the barcode here, so I'm going to do that real quick. So I'm going to select the barcode reader. You'll see it'll pull that up. And then on these ream furnaces down here at the bottom, they do have a barcode here, which I just got to get lined up there. And if you look close at the serial number here, the only difference you're going to see is that the serial number has an S in front of it that I want to delete on there. So I'm going to go ahead and tap on that. And if you press and hold your spacebar on your keyboard on an Apple, you can actually just use it as a cursor. So I'll delete that S on there. That'll wipe that out, and then I'll hit submit. Pretty cool little feature there. System profile. Now, the heating profile is set up on this. We just have to profile the system just like we do an air conditioning system. So this is a 90+ furnace, natural gas. I'm just setting this up as a single stage. This is a fully variable speed furnace, but we're going to test it on high fire only because that's the only way you can test this type of a unit. So I have it, my rated input's 90,000. I got my minimum supply gas pressure, that's 6 inches. That's the minimum allowable gas pressure for the regulator to adjust properly. I have my max gas pressure of 10 inches of water column, my nominal manifold pressure at 3.5, my rated efficiency I got down here off my tag at 94%. That calculates automatically my rated output at 84,600. I have my temperature rise from 40 to 70 degrees and my rated external static pressure at 0.5 inches of water column. So I'll go ahead and hit submit on that. Electrical information wise, it's a single phase evaporator fan. It's 120 volts and it's ECM, so I've got all that data in also. And at that point here, I'm ready to take measurements and start my test. Now, in the last video we showed how to use the AccuTools product. I do want to talk about, we have an ambient CO meter in here. And an ambient CO meter, I'm constantly monitoring my CO. So if I hit a couple keys here, you can see that I have this at 0 parts per million of carbon monoxide. So I don't have anything to worry about as far as CO in the space. And I'm okay to set my analyzer up and just run it in the room here. So I have the analyzer turned on, I have it zeroed out, but I'm going to go ahead and in my ambient CO test here, I'm just going to enter in 0 parts per million and hit submit on there. Now I can also activate my BluFlame on there and pull that in off the BluFlame, but the first go around here, what I want to do is get the furnace set up. I want to set the gas pressure to nominal 3.5. Then we're going to go out and clock the meter and it'll walk us through where to set the fuel pressure, and we'll do our combustion analysis and set up and get all that running. So at this point here, what I'm going to do now is simply go into my toolbox and I'm going to turn on all these different manometers here. Now, this may look a little bit crazy to you, but if you're like me and you want to get things done quickly, this is a small investment in tools that'll save you a ton of time on here. On a gas furnace, you have multiple pressure measurements you have to take. You should be monitoring your stack pressure or vent pressure. You should be monitoring your incoming gas pressure. You should be monitoring your manifold pressure, your total external static pressure, just for 4 of them on here. So you can see I got my vent pressure going up to my vent right here. I've got my incoming gas pressure right here. I've got my manifold pressure right here, and then I'm measuring total external static. I have a pressure tip down here at the bottom of the furnace. I have another one inside the furnace back here because I can't drill on either side to get in, so I had to go through the front of the furnace for the static pressure tip on there. Now, another cool thing I did on these was I put a small clip on here so that if I want to zero my manometers out, I can literally just fold my hose in two, open up this clip and clip it on here, and now the clip has got this sealed off so I don't have pressure on here. And when I take the hose off and zero the manometer, I can do that very easily on here. So just a little quick tip on here, especially with like gas, where you have on this side, on the inlet side, you have gas pressure all the time. It makes it really easy to zero the manometers if you have to. So I'm going to go ahead and literally all I'm going to do is turn on my Testo apps on here. So I got Testo Bluetooth Toolkit. I tap on that. If I go into my probe manager, what you'll see as I turn these guys on here is that they will come in automatically into the app. And I've got one up here for my supply air temperature, and I'm going to turn on one more here for my return air temperature, and you'll see all these guys coming in, automatically syncing in the application and bringing in their temperatures behind them. Now I'm going to go ahead and check my, my manifold pressure, and obviously there's no flame on this now, so I'm just going to go ahead and hit 0 here and zero that probe out. It says, you know, the probe's successfully zeroed, and then I hit the dismiss key, and that's that. And you can zero these at any one time. You can see I got my inlet pressure at 7.9 inches of water column. That probe, when it came on there, I'll go ahead and pinch this off for just a minute. We'll zero that just to see how close that holds at 0, because it's been a little while since I've zeroed these out here. So I'm just going to take that, pull the tube off this thing. You want to make sure when you're zeroing out these Testo manometers that you leave them flat on the surface that you're gonna adhere them to, or on a flat surface, because the diaphragm itself is so sensitive that if you take that manometer and you calibrate it this way and lay it on its back, it's going to affect the calibration. You can actually play with that and see that on your manometer. So I have this disconnected on my inlet pressure. It's reading 0.049. I'll go ahead and zero that out. So it's only 0.04 of an inch of water column off, or almost 0.05 of an inch of water column. So now that's zeroed out. I'll push this hose back on here. Now, when I do push the hose on, you're going to see it's going to go up to about 1.6 inches of water column, totally normal on there because I got this capped off and it's trapping pressure in between the hose and the manometer. So now when I open this back up to the gas, you'll see my incoming gas pressure is about 8 inches of water column. So I'm going to go ahead and turn this furnace up. We'll go ahead and get this set to 3.5 inches of water column, and then we'll go out and clock the meter and we'll get started. All right, so I'm going to go ahead and clock the meter. I'll hit clock the meter here, and we'll go ahead and wait for the meter to get to the top of the dial, and we'll push start. So we're just about there now, and start. So we get a question every once in a while, are gas meters really accurate? And yeah, they have to be. They're utility grade meters. You're billed on them, so they have to be a very accurate meter. Now what you got to realize is the heat content of gas varies, and that's why we set it up for an average heat content of the fuel, in this case 1070 BTUs for Ohio, because the heat content does go up and down a little bit. We need to let this go around 2 times here, so it's gone around once and let it go around 1 more time. And what this is doing is we're clocking the gas meter, we're determining how much gas is going through that meter so that we know where to set our fuel pressure at on our furnace. Because again, it's a nominal 3.5 inches of water column. We're just about the top here, so mark. All right, so it's telling us right now that our current input's at 88,615. We need to set that gas pressure for 3.62 inches. So let's go back inside and get that reset. All right, so we're going to go ahead. We got we captured the pressure when we first started. We went out and clocked the meter here. Real quick here, I'm just going to make sure that my manometer's still zeroed. So I'm just going to valve this off for just a second here on my manifold pressure. Pull my manometer hose off here, and I'm going to go into the toolbox and just re-zero it just to make sure that we're zeroed accurately. So tap on the probe manager. Down at the bottom it says manifold pressure. I'm going to hit 0, hit dismiss, and now that probe is zeroed in. Now I'm going to go back down to the bottom here and just reconnect this to the positive terminal, and I'm going to readjust my manifold pressure. So I got to disconnect the hose here now, and I'm reading full pressure on my manifold ports. You can see I'm reading about almost exactly the same as it was, 3.49 inches. Now this is where it's really cool. The manifold pressure we need is 3.59 inches of water column. So what I'm going to do is I'm going to dial this up, and you'll notice that as I'm dialing this up, you're seeing the BTU input increase at exactly the same time as my manifold pressure is. So we're continually recalculating that. So I'm going to tweak it up just a hair more, get it right at 3.59 inches of water column. So I'm right at 3.59, a little overshot it just a hair there. We'll back it back down a little bit. And we'll get that exactly where we want it. So 3.60, we're at 90,246 BTUs, well within the range there. We might tweak that just a little bit. Regulator's got to settle in just a hair, so they do require some fine adjustments, but we're well within now where I want to be, but I just like setting it up exact as I can. That's just me. So 3.57. Why do you do this? Because you can, right? 3.59 inches of water column, so now we're spot on there. So now I'm going to hit capture the pressure here. You can see I have my manifold pressure good. All my pressures are on spot on here, so I'm ready to go. So now I'm to the point where I want to do combustion test. So at the bottom here, you'll see I got a little flame, and I need to go into my toolbox for just a minute. I'm going to hit the back button here, and I'm going to connect to my BluFlame analyzer, which I have on, and it's going to hit connected. Now, there's a bunch of stuff in this menu here. Some of this is going to go away. This is for some of our testing with tying this into the MeasureQuick application. But I'll go to the home screen again and open up combustion measurements, and now there's a button here to start the analyzer. Now, I had the analyzer zeroed, and I got the furnace running, and it's always a good practice not to have your analyzer in the stack when you first start it. I'm going to pull out my plug for testing here, slide my analyzer in, pull it back about halfway, and now I'm going to let that go for some testing. It's going to take a few seconds for the readings to start coming in, but we'll start seeing our CO, O2, now you can see those readings start coming in, and I'm just going to hit the check mark at the top here, and we'll start watching it on the display. Now here's probably my favorite part with the whole application. Extremely visual. You know, one of my beefs with a combustion analyzer is it's just overloading you with numbers all the time, and what do those numbers actually mean? So what we did in MeasureQuick was what we always do is we built targets for everything. So when you profile that furnace and get it all set up, what you're doing is you're telling you what all the ranges are for everything. So you can see right now we got about 16 parts per million CO, 66% excess air, our combustion air temperature is 75 degrees, our stack temperature is 114. If I tap on the flame again, it's going to show us our dew point temperature, our O2, our CO2, and if I tap on it again, it's going to go back to stack temperatures and all that kind of stuff. And then we can scroll through here and look at all of our different readings. Natural gas furnace, supply air, 131.4, return air, 72 degrees, temperature rise, 59.6 degrees. I'm pulling those off the Testo probes. So you can see how I can get everything at once and I'm not running around taking all these different measurements. So this is very, very quick now as we're doing this. Automatic calculation of my airflow. So I'm moving 1,295 CFM of airflow across here, again, in the acceptable range. Fuel pressures at about 7 inches of water column. Remember, 6 inches is our cutoff on there, so it's okay still. It's also measuring our vent pressure here, which I have hooked up here. And the vent pressure is about 2.236, which is not really on the high end for this. We probably need to adjust the target for that, but I wanted to show you that anyway on there. It looks like there's just a little bug with that piece on there. And then our total external static pressure at 1.130 inches of water column on there, and that looks pretty well high on there. But again, on this furnace, if you had me talk about it before, my duct work is a tiny bit undersized on here. So again, that's a pretty normal thing for this. Then we go back to our manifold pressure. We're at 3.60 and our BTU input. So I can tell you without any doubt at all that this furnace is running the way that it should run, because I have all the targets, one after the other, laid out showing you where every reading should be for combustion analysis. Now here's the other thing we did on here. Your two primary gauges are combustion efficiency and safety. You always want to be looking at that CO air free. So you can see right now we're running about 25 parts per million CO air free, which is a very, very good reading for this furnace. Anything below 100 parts per million is we consider as an industry standard acceptable. The maximum allowable is 400 parts per million. So when that gets off that green section into the red section of the gauge, your CO is way too high and you need to do something with that appliance. You can see my efficiency is running around 91.5%, which is, again, is good for this appliance. My return air temperature is up a little bit high right now. If we scroll through to that, we'll see that my return air temperature is about 73 degrees, and that will affect the condensing of the appliance, and that's why we're seeing the efficiency drop down a little bit on there. But everything else looks pretty good on that. So as we go through here, again, manifold pressure, all those things done. Now the only thing we have to do left here is we need to get some electrical readings on here. So if I go into the electrical section, this is where I can measure my incoming voltage, my low voltage, flame rod microamps, polarity, combustion blower. So I'm going to take a minute. I'm going to do all those voltage readings, and then we'll come back in and we'll print the report. All right, so now we've got all of our electrical measurements in here. I'll go to electrical real quick. You can see my incoming voltage, my low voltage, my flame rod microamps, polarity, and we can go over all the electrical stuff in another video, but I just wanted to walk you through here all of those different measurements so you can get an idea what they are. I'll go ahead and hit submit, and then we'll go back here and we'll look at our we'll just print a copy of a report. So all I'm going to do here is hit save snapshot, and when I hit that snapshot, that's going to save all of the data that we have for this. I'm going to go ahead and hit results. I'm going to hit gas furnace test here. So this was done at 1:41 p.m. Hit share, export as PDF, and you can see now I got all my readings, my inputs, my efficiencies, everything that came off my analyzer, and all of this in the reports laid out so it's very easy to see and understand for you and for your customer. And you can see this entire test literally only took us a couple of minutes to do. So now, instead of wasting a whole bunch of time moving a whole bunch of things around and wondering if we're in the right range or not, I can literally do this in a few minutes, get a full furnace commissioning and setup, and actually have this thing working exactly the way that it was engineered to work. So very, very powerful stuff. Again, we're just about ready to release this thing. In fact, by the time you guys see this video, it should be out, and it's going to allow you to, again, do your job a lot faster and better than you've ever done it before. A couple other cool things I want to show you on this that we did I think are really, really interesting. I'm going to go back and I'm going to exit this product here. I'll save the data, exit this project, hit home. One of the things we did do though that probably is one of the neater things on here, if we go into the project and I'll just go ahead and change this profile on this system, I'll make this a 70%er for just a minute. There's still a ton of 70% efficient furnaces out there. Well, now we can actually capture the number of cells. So in this case here, I hit 3 cells on there, a 3-burner furnace, and when you're doing a combustion test, each one of those needs to be checked individually. So now when I hit submit on here and hit submit again and go to my home screen, you can see at the top now I have cell number 1. So if I tap on that and I do my combustion test, I'll go into combustion measurements here for just a minute, hit combustion, I'll stop the analyzer, and let's see here, actually let's hit submit. And then I'll go to cell 2 and go back in the combustion measurements. We'll just restart the analyzer again here. It'll pull in those values. And so now we're pulling in all the values off cell 2. I hit submit, go to cell 3. And I'd have to physically move that combustion analyzer over to that 3rd cell. Move to the 3rd cell, go back in the combustion measurements, hit submit, and then it's going to pull all the data from all 3 measurements into the analyzer. So again, very, very handy feature on there. Allows you to get all the measurements you need. We can print all those now on a single sheet of paper and allow you to see all the combustion tests. So let me go ahead and we'll just save that, save the snapshot, go back into results here, and let's see if that one, oops, I got to go back to the active test, and we'll look at the one that we just shot here. Share, export as PDF. And now you can see when we zoom in on that I have all my combustion analysis measurements for all 3 cells. Obviously we're checking the same stack on here, but you can see it pulled in all 3 readings. So now I don't have to print out 3 combustion tests for the appliance on here. I can do up to 6 cells on one furnace and get them all in at once. So again, another really, really powerful, cool feature of the application. The guys have knocked it out of the park this one, and it's like, for me, it's pretty darn exciting. So anyway, the Testo probes now are live. Testo probes are all mappable, so we got a full mapping solution on those. We've got multiple profiles for gas heating on there. It's going to open a lot of new things for you that you can play around with and really get to understand a little bit more what we're trying to do in MeasureQuick. So this is Jim Bergman for MeasureQuick. Thanks a lot for watching.